Hello everyone, I'm Bogdan. I'll be presenting the study on detecting feature flags in open source, done together with Jens, Juan, and Christian. Feature flags are a design pattern for separating code deployments from feature releases. They're essentially Boolean flags or Boolean options, configuration options that are meant to hide feature implementations behind them, such that you can deploy, for example, different versions of an application to different customers, or some can experience a certain feature, others need not to, and so on. There's a lot of hype. If you've been following the DevOps movement, there's a lot of hype around feature flags online. People are talking about how they can speed up releases, how they enable these canary or incremental releases, so gradually releasing to larger and larger fractions of your user base, and perhaps running experiments or A/B tests during these canary releases to detect how successful a particular feature implementation has been. Also, rollbacks is another stated benefit. It's easier to sort of remove a feature that didn't turn out to be successful by just disabling the flag that is hiding it. There's also a lot of discussion of drawbacks, mostly involving technical debt. Feature flags add complexity, they need to be removed at some point, and so this just contributes to more technical debt in systems. But really, despite all of this hype, there's very little academic research on feature flagging practices. The little academic research that exists focuses on a few commercial applications and virtually no studies of feature flagging practices across open source. And we think that this has a lot to do with the fact that there has been no way to systematically identify feature flagging in open source. And because of this, it's just unclear even how widespread and how diverse the practice is, let alone other things that are associated with it. So what we did is we tried to detect whether there's any usage of feature flagging in open source. And we started by trying out different heuristics across all of GitHub to detect open source projects that might be using feature flagging in meaningful ways. We tried looking for usage of certain libraries, and we saw that it's mostly so small and largely by now inactive projects that are using these libraries, and very few sort of large, active, popular open source projects that are using these standard libraries. It seems that the bigger projects are mostly building their custom solutions for managing feature flags. We also looked for traces of feature flags in documentation or wikis and issue discussions, found virtually none. We looked for file name patterns using regular expressions that might indicate files containing these configurations, these feature flags, the values assigned to these feature flags. Found very few, mostly around compilers, so flags that are meant to be permanent and so not the continuous deployment kind of flags. And at this point we were ready to give up, but then it dawned on us that really the very nature, right, the very characteristic that should distinguish feature flags from these more permanent configuration options, it might be an indication for their presence, and that is the fact that they're intended to be temporary. Flags are intended to be removed as soon as, for example, the feature is complete. Whereas configuration options are perhaps intended to be permanent. So with this in mind, we realized that commit messages actually are a great way to detect feature flagging churn, because they might indicate not just the addition of these feature flags, of new flags to a particular system, but also their removal. And with just sort of enough usage of feature flags, there should be many of these traces of feature flag introduction and removal that are visible in commit messages. There are lots of caveats here. We applied lots of additional filters to reduce the false positives that just so this keyword-based approach on commit messages would result in. You can find all of these details in the paper. I won't have time to go over them in the talk right now. So with this in mind, we compiled a data set by mining these commit messages across all of GitHub. We found over 3,200 projects that we suspect with high confidence are using feature flagging and this continuous deployment sense in meaningful ways. So not just configuration options, but sort of really feature flags. And we manually validated 100 of these projects to make sure that they indeed use feature flagging in this DevOps way. You can find the details in the paper for how we did this manual validation. The projects, some of them are expected, like the Chromium web browser and then others, but there are also many interesting and unexpected projects in the dataset, like an application used in Finland for building and land permitting online. Again, you can find all of these on our Zenodo page or the GitHub repo. So this was our first contribution, the dataset itself. Our second contribution is an empirical study of this dataset, looking at when flags are introduced and how they're used. I'm showing you here in this plot a survival curve of the 7,500 or so flags that we manually identified across these 100 projects. And you can see, for example, that about half of the flags are removed within 15 months of their introduction, but there's still about 25%, a quarter of flags that remain in the code for at least 8 years. The other thing that we did is run a multiple regression here to see if there's any correlation between different practices or stated best practices for managing feature flags and the lifespan of the flags themselves. The strongest result we found, and you can find all the details for how we did this in the paper, was that high flag ownership is associated with shorter flag lifespan, significantly shorter. So this is when the same developers that were responsible for introducing these feature flags into the systems are the ones eventually removing them. We call this high flag ownership, as opposed to other developers being responsible for the removal of these flags later on. This practice of owning feature flags correlates with significantly shorter flag lifespan and potentially also less technical debt as a result of this. So this was basically our study. It's a public data set of lots of interesting open source GitHub projects that use feature flagging in meaningful ways. And an analysis of practices in 100 of these projects that we had a chance to manually confirm that they were indeed using feature flags. And you can find more details in the paper, and you can find the data set online and on our GitHub repo. Thanks.